Bismillahirrahmanirrahim. I'm Engineer Muhammad Suhaib, and today we will discuss the lecture number 2 of engineering mechanics, which is about the geometry, trigonometry, and vector algebra. So if you haven't watched the lecture number 1 of engineering mechanics, I would recommend that kindly watch that lecture first and then move on with the lecture number 2. So the contents of today's lecture is that first of all we will discuss some basic geometry which is used in engineering mechanics. Then we will discuss some basics of trigonometry. After this we will discuss that what are vectors and what are scalars and what are the vector operations. We will perform some practical problems of all of these concepts at the end. So the basic geometry which is used in engineering mechanics. So first of all, we have to know that what are angles, what are exterior angles, what are interior angles. So this slide shows the illustration of exterior and interior angles. Here you can see that this is a polygon with 5 sides, and these angles which are shown with red shading are known as the interior angles because they are inside the shape, and those angles which are outside the shape are known as exterior angles. Here you can see in case of triangle as well, this angle is an exterior angle. Here we can see that if there are two parallel lines and another line passing through these two lines at distinct points, so this line is actually known as transversal. So if we are measuring this angle or if we are measuring this angle, these would be known as exterior angle, and the angle inside these two parallel lines will be known as interior angle. So if we are interested to find these angles, or we are interested to find these angles, these would be known as interior angles. And now we have discussed that this line is known as transversal, and now the line and the angles which this line makes with these two parallel lines are known as transversal angles. And there are some interesting properties of this transversal angle. For example, these are known as alternate interior angle, this angle 1 and this angle 2, and this is the property of this line. This angle 1 and this angle 2 would be equal because these two lines are parallel. So if this line makes an angle of 45 degree with this line, so this angle will also be 45 degree. Similarly, this illustration shows the corresponding angles. This means that if this is angle of 45 degree, this angle will also be 45 degree. In the same way, these are known as alternate exterior angles because they are on the exterior side, and the property of this angle is that these two will also be equal. If this angle is 30 degree, this angle would also be 30 degree. In the same way, these are consecutive angles because they are on the same side of the line. This is a transversal line, and these two angles lies on the same phase or on the same side of the line, so this will be known as consecutive angles. If these angles lie on that side, then they would also called consecutive angles. Then we have some other angles as well. For example, if these two lines are passing through each other, so the angle opposite to each other will be known as vertical. Here you can see there are 3 lines, and this line makes an angle of with this line and also makes an angle with this line. So these two angles will be known as adjacent angles. Then we have some other angles like angle of elevation and angle of depression. So if we draw a reference line or a line which is passing through the eye level of a person, then any angle which is above this line will be known as angle of elevation, and any angle which is below this line will be known as angle of depression. For example, this is a person which is standing in front of the Eiffel Tower. If we draw a line which is passing through the eye level of this person, and if this person is looking at the top of the Eiffel Tower, then he will be making or she will be making an angle of elevation. And if a person is standing at the top of the Eiffel Tower, and if we draw a line which is passing a horizontal line which is passing through the eye level of this person, and if this person looks down, then the angle which is made with this horizontal line will be known as the angle of depression. Okay, so far we have discussed some basic geometry which is used in engineering mechanics, and now we will solve some examples. which will give us some more insights of all of these properties. So in this example we are given two parallel lines and another transversal line which is passing through these two parallel lines. This transversal line makes an angle of 110 degree with this horizontal line, and we are to ask that what is the angle theta that this line makes with this horizontal line. So in order to solve this question, there are certain ways, there are many ways you can solve this question. The one which I am using, first of all, we will calculate this angle which is that the line makes with this horizontal line. If we are able to find this angle, then by using the alternate interior angle properties, we can easily find this angle theta. So we know that this horizontal line, the total angle of here will be 180 degree. We know that this whole angle is 180 degree, so we can find this angle phi very easily. So this is phi plus 110 degree will be equal to 180 degree. From this we can find the angle phi, which is 70 degree. Now by alternate angle properties, we know that this angle, this two angle will equal to this one angle. So this means that this phi angle is equal to this theta angle, and this is 70 degree. So we have calculated this angle 70 degree. Similarly, you can practice all of these examples by your own. In this example we have to find the angle x, and this we have to find the angle x, with this we have to find the angle x, and similarly and so on for the all of the problems. Now we have another problem in which there is a member, metallic member, which is supported by a pin support at point A and a roller support at point B, and there is another member which is connected with this member at point C with a pin, and a force of 800 Newton is acting on this member, and we have to find calculate the angle which the force F makes with x-axis and n-axis. So we have to find the angle of inclination of this force with this x-axis and with this n-axis. So there are similarly there will be so many ways in which we can calculate, we can solve this problem. The one which I am going to use will be discussed here. So first of all, we have to find what is the angle of this force with the x-axis. If we can find this angle, then the angle with n-axis will be calculated very easily. So in order to do that, first of all we will draw the line of action of this force, which can be seen here. Then we will draw the x-axis and y-axis along the force, so that you can easily visualize the problem. And now in this problem we have to find this angle theta. If we can find this angle theta, we can find other angles as well. So in order to make this problem easy, I will shift this axis to this point so that I can draw a triangle, and then we can solve their triangle. So I have just drawn the axis over this point, and now we can see that there a triangle have been made with this point. In this triangle we know this 40 degree. We can find this angle B very easily. If we can find this angle B very easily, then automatically we can find this angle theta by adding all of the interior angles. So first of all we have to find the angle B. We are already given the inclination of this member, which is 60 degree, and from this 60 degree we can find the angle B. How we will do that? We know that this total angle is 180 degree, and this 180 degree contributes of this consists of this 60 degree and this angle B. So this means that angle B plus angle 60 degree is equal to 180 degree. From this we can find angle B, which is 120 degree. Now we have find this 120 degree, and from the laws of triangle we know that the sum of all the interior angles of triangle is 180 degree. So from this equation we can easily find this angle theta, because we know that angle B plus angle theta will plus this 40 degree will be equal to 180 degree, and from this we can find the angle B, which is the angle theta, which is 20 degree. So this means that this force F is making an angle of 20 degree with the x-axis. This means that this force F is making an angle of 20 degree with this negative x-axis. If you want to find the angle of the angle of the force with the positive x-axis, this will be simply 180 minus 20 degree, which will be 160 degree. And if you want to find the anti-clockwise angle of this force, this would be simply the clockwise angle of this force, sorry, this would be simply 180 degree plus 20 degrees, so it would be 200 degree. So these are different views with which you can find the angles. Now we have found the angle of this force theta with the x-axis. Now we have to find the angle with the n-axis. For this, again, we will first of all we will draw the we actually want to know this angles phi, and by the alternate angle properties we know that if this is 60 degree, this will also be 60 degree. Now we have this 60 degree, and this total angle will be 90 degree. From this we can find that this angle is 30 degree. So this means that the angle between the n-axis and the x-axis is actually 30 degree. Now we will draw these axes along the force. Here we can say this is the y-axis, this is the x-axis, and this is the n-axis. And this angle is 30 degree. We have found it. And from the previous example, we have already found this angle, which is 20 degree. Actually, we have found this angle, which is 20 degree, but by alternate angle properties, if this is 20 degree, this angle would also be 20 degree. Now the total angle would be 30 plus 20, so it would be 50 degree. So very easily we have found the angle of inclination of this force with the n-axis and x-axis. With the x-axis, it have made an angle of 20 degree, and with the n-axis it have made an angle of 30 degree, an angle of 50 degree, sorry. Now there is some other exercise problems which you can solve by your own. This is for your practice. So let's start with the basic trigonometry. So trigonometry is actually based on the right angle triangle. So we have to know what are the properties of right angle triangle. So right angle triangle is the one in which one of the angle is 90 degree and other two are less than 90 degree. This angle is usually known as theta or alpha, and this angle is usually known as beta. Now the side which is adjacent to the angle and with the 90 degree, it is known as base. Okay, and the other side will be perpendicular. So the side which is opposite to this angle would be perpendicular if we are considering this angle. If we are taking our reference as this angle theta, then the side which is opposite to theta will be perpendicular, and the side which is adjacent to this angle theta and which is adjacent to the perpendicular degree will be base, and the remaining side would be hypotenuse. But if we are considering, or we are taking our reference angle as beta, then the side which is adjacent to this angle beta and which is adjacent to perpendicular degree would be base, and the side which is opposite to this angle beta would be perpendicular, and the other side would be hypotenuse. The equation which I have written down over here is with reference to the angle of theta. So as I have already discussed, that if this is the angle of theta and this is our reference angle, then this side which is actually adjacent to this angle, and it is adjacent to the perpendicular to 90 degree as well, so it would be base, and this side would be perpendicular, and the side which is opposite to the 90 degree would be hypotenuse. And these are simple trigonometric equation in which sine theta is actually perpendicular divided by hypotenuse, which is p by h. Cos theta is equal to base divided by hypotenuse, which is b by h, and tangent theta is perpendicular divided by base, which is p by b. Now we have discussed that what is perpendicular, what is base. So can you tell me that what are the perpendicular and base in the following figures? So I would recommend that kindly take a pause here, pause the video for 2 and 3 seconds, for 2-3 minutes, sorry, and solve these problems and find out that what are the bases and what are the perpendiculars in the following examples. For example, in this figure you can see that the reference angle is 29 degree and it is here. Now I have told you that the side which is adjacent to this angle and which is adjacent to the 90 degree, this would be base. So in this example, the 20 meter is base and x is the perpendicular and this side is the hypotenuse. Similarly, in this example, this y-axis, this y-angle is actually our reference angle. So the side which is adjacent to this angle, and it is adjacent to the 90 degree, it would be base. So the 15 centimeter is the base, this line is the perpendicular, and this line, the 23 centimeter line, is the hypotenuse, and this is the same for all other. Okay, so now we have discussed the basic trigonometry which involves in the engineering mechanics. So now we have very practical applications of this trigonometry. In this problem, actually, we have to find the size of the overhang. Actually, in this problem, in the designing a house, an architect wishes to determine the amount of overhang of a roof that it shades the entire south wall at noon during the summer solstice when the angle elevation of the sun is 81 degree. Minimally, how much overhang should be provided for this purpose? So actually, there is a house, and this line shows the south wall of the house. And here you can see that in summer season, the sun actually makes an angle of 81 degree with the horizontal with the earth. So this means that this angle is actually the angle of elevation. So the sun makes an angle of 81 degree with the earth. So this means that this angle, that the sun makes an angle of 9 degree with the wall. And actually, what we have to find, that the height of this wall is actually given, which is 11 feet, and we have to find the length of x, which actually represents the length of overhang. In such situation in which the sunlight do not enter the house. So what in this problem has have been asked, that we have to find such length in which in which the summer season the sunlight cannot enter the house. So here you can see that here a triangle have been made with this overhang and this wall of the house, and this is the line which represent the sun rays. So this triangle has been represented over there. Here you can see that this side of the triangle actually shows the length of x, which is actually the length of the overhang, and this side shows the height of the wall, which is 11 feet, which is already given. And this angle is the angle of elevation of the sum of the sunlight in the summer season. So by subtracting this 81 degree from 90 degree, actually we will find this angle theta, which is 9 degree. Now our reference angle is this angle theta, which is 9 degree, and I have already told you that if the line is intersecting with the angle theta with reference angle, this line would be the base. So in this case, the base is 11 feet, and the perpendicular is x, which we have to find, and the hypotenuse is this line, which is actually showing the sun rays. So by using simply the tangent theta, we can find the tangent theta is perpendicular divided by perpendicular divided by base. So this x is actually perpendicular, so it will be on the numerator, and the 11 feet which shows the base, it will be in the denominator. So this means that tangent theta is equal to x divided by 11, and actually this theta which we have already defined is 9 degree. So tangent 9 degree will be equal to x divided by 11. So multiplying this 11 with the tangent 9 degree, we will find that the minimum size of the overhang should be 1.74 feet. So if the architect provide an overhang of 1.74 feet, then no any sunlight will enter the house during the summer season. Now this is the another part of the same problem, in which with the overhang found, how far will the shadow of the overhang come down the wall at noon during the winter season, and during the winter solstice when the angle of elevation of the sun is 32 degree. So now in the winter season, the angle of elevation actually decreases of the sun rays, and it has been given this angle of elevation of the sun rays during this winter season is 32 degree. And now we have to find, we have actually already defined this length of x, which is the length of the overhang, which comes out to be 1.74 feet. And in this problem, you have to find that what would be how far will the shadow of the overhang come down. So it means that you have to find this line, this line in this case, and actually you have given this angle is 32. So the interior angle would be 90 minus 32, which would be about 58 degree, I guess. 58 or 68, 58, sorry, 58, yeah, this angle would be 58 degree, and you have already find this side, which is 1.74 feet. So you can easily find by doing the tangent 58 degree will be equal to this x divided by, no, this 1.74 feet divided by the height of the shadow, and you can say it why. So by dividing this 1.74 with the tangent of 58 degree, you can find what would be the length of the shadow in this winter season. So that's all, and you have to practice this problem in your home. Now, some other properties of the trigonometry is that the law of sines, which states that if we take the sine of this angle alpha and divide it by this side A, it would be equal to the sine of this angle beta divided by the this side B, the length of this side B, and it would be equal to the sine of this angle gamma divided by this angle C. In words, the ratio of the sine of an angle to its opposite side is the same as the ratio of the side of either of the other angle to its opposite side. And we will use this with a practical application. Now this is the practical application of the law of sines, and in this problem actually to measure the length of the length D, which is this side. This shows the length of the lake or pond. A baseline AB is established. This baseline AB, which measures 125 degree, is established and measured by to be 125 meters. Angle A and B are measured to be 41.6 degree and 124.3 degree respectively. How long is the lake? So you have to find the length of this lake, which is B, and you can do it very easily by using the law of sine. You know the length of this side, and you can find this angle very easily by adding all of these lines and equating it with the 180 degree, because the sum of all the interior angles is 180 degree. So you can find this angle very easily, then taking the ratio of the sine of this angle with this side, and taking the ratio of the sine of this angle with this side, you can find the length of the lake, which would come out to be 341 meter. Then this is another problem which shows the practical application of law of sines. The tallest tree in the world grow in Redwood National Park in California. They are taller than a football field is long. They are taller than a football field is long. Find the height of one of these trees given the information in the figure. So you have been provided the information that you have been provided two angle of elevations, which is 37.10 degree, 37 degree 10 minutes, and here this line makes an angle of elevation of 44 degree and 0 minutes, and the distance between these two lines is 10 feet, is 100 feet. So you can find the height of this tree very easily, and the answer to this problem is 237.3 feet. Now, other than law of sines, we have a law of cosines as well, which states that if we take the square of this side, it would be equal to the sum of the squares of these two sides, which is b square plus c square, minus 2bc, 2 times this side and this side, which is bc, and take the cos of alpha. So this is the cos of alpha. So this means that if we are considering this angle alpha, and we have to find what is the length of this side, so we can do it very easily if we can use this trigonometry law, which states that a square is equal to b square plus c square minus 2bc cos of alpha. Similarly, b square would be equal to a square plus c square minus 2ac cos of beta. In the same way, c square would be equal to a square plus b square minus 2ab and cos of gamma. This is a practical application of the law of cosine, in which it has been asked that a surveyor has taken the measurement shown in figure. Find the distance across the lake. This is the distance across the lake. Round answer to nearest of 10. So in this example, you have to find the length of this side, and you have been provided this angle 70 degree, and this side of 900 feet and this side of 800 feet. So you can use the law of cosines very easily. That the length of this if this length is if we suppose that this length is x, then x square would be equal to 900 square plus 800 square minus 2 times 900 into 800 into cos of 70 degree. So you can find this length very easily. These are some exercise problems which you can solve it by your own to practice the trigonometry, to practice the basic geometry. These are other two problems you can solve it by your own, and these problems have been taken from the R.C. Hibbler book. Now we have to discuss what are scalars and what are vectors. A scalar is a physical quantity that can be completely specified by its magnitude. Examples of scalar quantities include length, mass, time, volume, work, energy, and power. A vector is any physical quantity that requires both magnitude and a direction for its complete description. Vector quantities must obey the law of parallelogram of addition as described later in this lecture, and examples of vectors encountered in statics are force, moment, etc. So in case of scalar, you have to provide only the magnitude there. What is the magnitude of the property? And it is enough. But in case of vectors, you have to provide two things. You have to provide the magnitude, that okay, what is the magnitude of that property or that of that thing, and then what is the direction of that property. So you can for the definition, for defining the property completely, you have to given these two informations. First one is the magnitude, and second one is the direction. In order to represent a vector, you need an arrow, and the length of this arrow actually shows the magnitude of the vector, and the angle of inclination, or the angle with this vector makes with the x-axis or the horizontal axis, will give you the direction of this vector. You can represent a vector with a bold letter. Here you can see that this is vector A. The starting point of the vector is known as the tail, the ending point of the vector is known as head, and the line which the vector passes through is known as line of action of the vector. Now there are many types of vector. For example, the first one which we have discussed here is a free vector, a vector that maintains the same magnitude and direction regardless of its position. For example, in this case, this is a box, and let's say a vector or a force is acting on this box in this direction. Now if we apply the force over this point, if we apply the force over this point, or we apply the force on any point along this line, it would not change the effect of the force, and it will act in the same line, and it will produce the same effect as it is produced in here. So this means that this is a free vector, and we can move this vector along the y-axis in the perpendicular direction. Similarly, we can have sliding vectors, which is a vector that can be applied at any point on a body so long as it is along its original line of action and does not change its effect on the body as a whole. This vector maintains direction and magnitude, and it has a unique line of action in space but not a unique point of application. So here in this example, you can see that this is a force which is actually a vector, and it is applied on the body, and this body is supported by a pen and a roller. The pen is at point O and the roller is at point C. Now this force, if it is applied on the point B or if it is applied on point A, it follows the same line of action and it produces the same effect on the body. But if this force is applied on this point C, then the effect would be different, and if it is applied on point O, then the effect would be different. So this kind of vector is known as sliding vector because we can slide this vector only along its line of action. Then we can have fixed vectors. A vector that has a unique point of application, it can be treated as a sliding vector by being slid along its line of action in order to examine the external effects it has on a body. So a fixed vector, we cannot move it would be always applied on the same point. In order to explain that what is a fixed vector, we have taken an example in which we have assumed a deformable body. So we have a bar having a length L, and this bar is actually deformable. So if we apply a force F, this will be deformed. If we take a section at the end of this bar and apply a force P on this bar, then as this bar is deformable, so the length of this bar would be increased from L to L dash. Here we can see that this is the increase in length because of the force P, and the total length of this bar would be L plus L dash. In another case, we have taken the same bar which is having a length L, and now we have taken the section at the midpoint or at the half of this bar, and we are applying a force of P on this midpoint. Now the deformation would cause from this point to this point, and this deformation will be having a length of L dash, and now the total length of this bar will be L by 2 plus L dash plus L by 2. Now the difference between these two cases is that in this example, the point of application of the force P is the end of the bar. In this example, the point of application of this force P is the middle of the bar, and it produces different effects. So this means that we cannot slide this force along its line of action, and we have to maintain the point of application of this force, and this is known as a fixed vector. Because when the force is applied on this end point, it have produced deformation in the whole bar, and it have disturbed the atomic properties of the whole bar. But when this force is applied on this midpoint, it have just disturbed the atomic properties along its half length. This half length of this bar is not disturbed. So this means that this force P has different effects in this case and in this case. So we cannot assume that this force is actually equal to this force. They are equal in magnitude, but the point of application of these two forces is different. So this means that they are fixed vectors, and we have to maintain the magnitude, and we have to maintain the point of application of this force as well. Now we have negative vectors as well. Negative vector is a vector having the same magnitude as vector v, but direction in the sense opposite to v as shown in the figure. So negative vector is having the same magnitude. So for example, if this is a vector of v and it have a magnitude of, let's say, 25 Newton, then the negative vector would be having the same magnitude of 25 Newton, but the direction of this vector would be opposite to this vector. This is known as negative vector. Now we have to discuss the operations of the vector operations. So first of all, let's discuss the multiplication of a vector by a scalar. If a vector is multiplied by a positive scalar, its magnitude is increased by that amount. For example, let's say there is a vector A, and if we multiply the vector with the scalar 2, the magnitude of the vector A would be 2 times A. Similarly, multiplying a negative scalar will also change the directional sense of the vector. For example, this is a vector A, and if we multiply it with a scalar -1, then the magnitude of this vector would be -1 times A, which is -A, and the direction would also become opposite to this A. So this would become a negative vector. Similarly, if we multiply this angle A with a scalar of -0.5, then the magnitude of this vector will become -0.5a, and the direction would also change to the opposite direction. Now we have to discuss the addition of vectors. So vector can be addition by parallelogram law of vectors. This law states that vector must obey the parallelogram law of combination. This law states that two vectors, for example, this is v1 and this is v2, treated as free vectors. So they are treated as free vectors, so we can move them anywhere. May be replaced by their equivalent vector v. This is the equivalent vector v, which is the diagonal parallelogram formed by v1 and v2. So if we drag this force v2, and if we join the ending point, the tail of these two vectors, and if we draw a line parallel to this vector v having the same length, and we draw another line which is v1 having the same length of this v2, then the diagonal of this parallelogram would be the resultant, and it would be the sum of this vector 1 and v2. So we can say that this vector v is actually equal to v1 and v2. This combination is called the vector sum, and we will use this in the last of this lecture. Similarly, the triangle law of vector is actually the head to tail rule. It states that the two vectors v1 and v2, again treated as free vectors, may also be added head to tail by the triangle law. So if we move this vector 2 to the head of this vector 1, so here you can see that the tail of this vector 2 is actually meeting with the head of this vector v1. So the resultant vector, or the addition of this vector v1 and v2, would be a vector whose tail is joining with the tail of the first vector, and its head would be joining the head of the last vector. Now we have to discuss that what are actually the components of a vector. Any two or more vectors whose sum equals to a certain vector v are said to be the component of that vector. For example, this vector v is actually addition of the vector v1 and v2, as we have discussed in the explanation of the law of parallelogram. So this vector v is actually the combination, or it comes out from the sum of the vector v1 and v2. So we can say that the vector v1 and v2 are actually the components of this resultant vector v. Similarly, there can be rectangular components, and rectangular components are those components which are perpendicular, mutually perpendicular to each other. It is usually the most convenient way to deal with the vectors components which are mutually perpendicular. These are called rectangular components. So let's say this is a vector v, and these are the components of this vector v, which is vy and vx, and these components are actually mutually perpendicular to each other. So we can say that these are rectangular components of this vector, and we can easily resolve these vectors by using the simple trigonometry. If you want to find the angle of inclination, this theta of this resultant force with the x-axis, we can use simply the tangent theta, which is equal to the perpendicular vector component, which is vy, divide the horizontal vector, which is vx. So we can easily find this angle theta, and these components are known as the rectangular components of the vector v. And in the coming lectures, actually we will be using only this property of vectors. We will find the rectangular components of the vectors, and then we will proceed with our problem. And you will use these properties very often in the mechanics of solids, in the structural analysis, in the structural dynamics, and other courses of the civil engineering. Okay, so far we have discussed the vector operations in very detail. Now we have to solve a practical problem of these vector operations, so you can have very deep insights of all the vector operations. So this is a practical problem in which we have determined the resultant force Fr of the two forces F1 and F2. So there is a hook, and it is connected with a fixed support through a wall or anything over here. And there are two forces, F1 which is acting at an angle of 30 degree with the y-axis, and the magnitude of the force F1 is 250 pounds, and the force F2 is acting at a degree of 45 degree with x-axis, and this angle would also be 45 degrees, so it makes the same angle with x-axis and y-axis, and the magnitude of this F2 force is 375 force. So what actually in this problem it has been asked that if we remove these two forces, then what will be an effective force Fr, which will represent the resultant force acting on the hook, and we have to find the magnitude of that resultant force Fr, and we have to find the direction of the force Fr. This means that we have to find the angle of inclination of that force Fr. So first of all, we have to draw the vector diagram of this problem, and then we can solve it very easily. So first of all, we will draw the axis, the x-axis and y-axis. This line shows the x-axis and this line shows the y-axis. Now we will draw an arrow which will show the force F1, and now the length of this line would be 250 units. So it means that this can be 250 centimeters, it can be 250 inches, it can be 250 feet, whatever it is. But it will be having a unit of having a length of 250 units, because the magnitude of this force is 250 pound. And this line would be having an angle of 30 degree with the y-axis. And this here you can see that this line having an angle of 30 degree. Now this is the another line, another arrow which shows the force F2, and now this line will be having a length of 375 units. It can be 375 millimeters, 375 centimeters, 375 inches, whatever it is. But this line is actually showing the force F2, so the length of this line should be 375 units, and the angle of inclination of this line would be 45 degrees. So we have defined these forces very accurately. Now we will draw another line parallel to this line F2, and will be having the same length as this line F2, because it will be having the same magnitude. because it is a requirement of the law of parallelogram. Now we will draw another line which will be equal and parallel to the line F1, and it will be joining the ending point of the line F2 and the ending point of this parallel line which we have drawn. So now you can see that a parallelogram have been found, and the resultant force would be produced from this point of intersection of the forces to this point of intersection of the two construction lines. Now in this parallelogram, we actually know the length of this line, which is 250 units. We know the length of this line, which is 250 units. We already given the length of this line, which is 375 units, and the length of this line, which is also 375 units. And here you can see that three triangles are actually produced in this. Two triangles are actually produced in this figure. So it means that in both the two triangles, we know this the length of the side of either two sides. So if we are able to find the length of the third side, actually it would be the magnitude of the resultant force. And if we are able to find the angle of inclination of that black line which shows the resultant force, we will be actually properly define the force Fr, its magnitude and its direction. So if you see this problem, in this problem, if we consider this triangle on the lower side, in this triangle we actually know the length of this side F1, which is 250 units, and the length of this side is 375 units. And in order to solve a triangle, you have to know at least three parameters, only any three parameters. It could be the three sides, the length of the three sides, it could be three angles, it could be two angles and one side, and it could be two sides and one angles. So in this problem, we know actually we know only the length of two sides, and if we are able to find any one of the angle, we can actually solve this that triangle. In order to find the angle, what I will do, I will first of all I will find this angle phi. This angle phi actually shows the inclination of this force Fr. If we are able to find this angle phi, we can easily find the angle of inclination of that force. So in order to find this is the angle of inclination of this force with the x-axis. In order to find the one angle which I was discussing in later, so this would be that angle which we can find very easily. In order to find this angle, I will I will reproduce this side. In order to find this angle, I will reproduce this line in the backward direction. Here you can see, and this line would be having the same direction as that of this line F2. Now here you can see that this angle would be 45 degree, because this is the 45, this angle is 45 degree, so this angle would also be 45 degree by the alternate exterior angle properties. Now this total angle would become 45 degree plus 30 degree, which would be equal to 75 degree. Now this line and this line is actually are at an angle of 75 degrees. So this means that this angle is also 75 degree, because this line is parallel to this line F1, and that line is actually equal to this line, is parallel to this line. So this means that the angle between this and this line is a 75 degrees. So this means that we have found this angle 75 degree. Now we have one angle and we have two sides, so we can easily find the length of this other side Fr by using the law of cosines. Now the law of cosines states that Fr square would be equal to the length of this side would be equal to F1 square, the square of this line, plus F2 square, the square of this line, minus 2 times F1 F2 into cos of x. Now this x would be the angle which is opposite to this line Fr, which is our reference line. So this x will be 75 degree. So by putting these values, F1 is actually having a magnitude of 250 pounds, F2 having a magnitude of 375 pounds, and x is actually 75 degrees. So we will find that the Fr would be equal to 393.2 pounds. So now we have successfully found the magnitude of the force Fr. Now we have to find the direction of the force, because in the previous lecture we have discussed that force is a vector quantity, and in order to define a force completely, we have to define its magnitude, we have to define its direction, and we have to define its point of application. So we have found the magnitude, which is 393.2 pound, and now we have to find the direction. So we can easily do it by using the sine laws. The law of sine states that sine of theta, which is this sine of phi, sorry, which is this angle, divided by f1, which is opposite to this angle, and would be equal to sine of 75 degree, which is this angle, divided by the fr, which is opposite to 75 degree. So now sine of phi divided by 250 degree, 250 pounds, because f1 is having a magnitude of 250, and sine 75 would be equal to 394. Actually, it is a typo. It is 393.2 pound. So by doing the simple mathematics, we can find that phi is actually equal to 37.89 degree. So this angle, which is the angle of inclination of the force, resultant force with the F2 force, is actually 37.89 degree. And if we are interested that what would be the angle of inclination of this force with the x-axis, we can do it very easily, because this total angle is actually 360 degree. We know that this total angle from this positive x-axis to again this positive x-axis is 360 degree, and it actually comprises of this 90 degree plus 90 degree plus 90 degree, which becomes 270 degree, and this angle is 45 degree, and this angle is 37.89 degree. So if we subtract all these angles from the 360 degree, we can easily find the angle theta. So theta would be simply equal to 360 degree minus 270 degree minus 45 degree minus 37.89 degree, which would become 7.11 degrees. So we have very easily find the angle of inclination of the force as well as the magnitude of the resultant force. So it means that if we remove these two forces, so the resultant effect of these forces can be replaced by a resultant force Fr, which will be having a magnitude of 393.2 pound, and this angle would be acting at an inclination of 7.11 degrees. So the angle of inclination of this resultant force would be 7.11 degree, and it will produce the same effect as these two forces are producing simultaneously. So that was all about the problem, and if you guys have any kind of question, you can ask in the comment section. It was a very practical problem. I have shown some other problems as well. You can solve it by your own, and you can refer to the book, which is the Structure Analysis or Engineering Mechanics by R.C. Hibler. Here you can find some other problems as well, and you can solve it for your own practice. So that was all for the lecture number 2. If you guys have any kind of comments, any kind of questions, any kind of doubts, you can ask in the comment section. Thank you so much.